My name is Dorota Napierska. I'm the Toxic-Free Circular Economy Policy Officer at Zero Waste Europe, and I will be chairing today's webinar. For those who don't know, Zero Waste Europe is a European network of communities, experts, and organizations working to eliminate waste, but also harmful chemicals from our society. Today's webinar will take 1 hour and will provide a comprehensive overview of the toxic chemicals associated with Nurdles of plastic pellets, and how this knowledge can strengthen efforts to combat Nurdle pollution. By understanding the chemical risk these plastic pellets pose, participants will gain valuable knowledge to advocate for stronger environmental protections and effective mitigation strategies. Before I will introduce the 4 excellent speakers for the event, I would like to briefly mention housekeeping rules. Webinar is being recorded and will be shared by Fidra afterwards, so please turn camera off if you don't want to be filmed. Also, please put the microphone on mute throughout the presentations. And please put any question in the chat as we go. There will be a dedicated Q&A session at the end where we will address those questions. So now, without any further ado, I would like to introduce our first speaker, Teresa Karlsson. Teresa did her PhD at the University of Gothenburg in Sweden, looking at sources and fate of plastic particles, including pellets. Today, she works as a science and technical advisor for the International Pollutant Elimination Network, a global network of over 60 civil society organizations in 127 countries. And in her work, Teresa actively engages in international partnerships and citizen science projects, bridging local insights with global policy to reduce and eliminate the harm to human health and the environment from toxic chemicals. So, Teresa, the floor is yours.
Thank you very much, and thank you to Fidra for organizing this event. Good morning, good afternoon, good evening to you all. I will start by sharing my screen here. Thank you all for joining. The first time that I looked at plastic pellets specifically was during my PhD, and we wanted to understand how they ended up in the environment and how they spread and what could be done about it. So we looked outside a production facility in Sweden, and during just 1 hour, we saw that 3,870 pellets were released. And in addition to that, there were over 500,000 other plastic fragments and pre-production materials. So over 500,000 in an hour from one place. And when we looked at other areas, other places in the area where the plastic pellets were stored or handled, we could see that the situation seemed to be quite similar there. Now, this is not an isolated event. It's not an isolated place. This is likely quite representative of how it is in many situations, which is maybe why we find plastic pellets in so many places around the world. And with the plastic pellets come not only the physical harm a plastic pellet can cause, such as one thing that's been often studied is the fact that if seabirds eat the plastic pellets, they think it's food, and then it can block their intestinal canal. But aside from that, aside from the physical harm that the plastic pellet causes, are also a set of potential chemical harms that the pellets can cause. Because plastics are chemicals. They're made from different intentionally added chemicals, such as additives and polymers, but also non-intentionally added substances. And we are seeing in study after study that plastic pellets do have hazardous chemicals associated with them. Here's a study that we did together with Professor Takada, who will be speaking later, where we looked at plastic pellets from 23 beaches around the world. And we found hazardous chemicals from all of these beaches. What we also found was that the concentration seemed to be particularly high in countries from Africa. But we did find them in all of the locations that we sampled in a wide range. So this shows that toxic chemicals in plastics are being transported globally, even before the plastic materials become plastic products. Now, the first study that I did was more on the continuous release of plastic pellets. Then there's also the devastating releases that happen during shipping accidents. One such accident was in Sri Lanka a few years ago that Hemantha will talk more about later. And in that one, billions plastic pellets were flooding the beaches. But this accident also caused a lot of different chemicals to be released. And plastics are not inert materials, so they often absorb a lot of different chemicals that are in the surroundings. And there was clear impacts from this spill already from the beginning. Already after months, 258 turtles, 43 dolphins, and 6 whales had stranded on the beaches in the area. And when my colleagues were in Sri Lanka, were talking to fishermen, they talked about changes in the sea and strange odors and strange colors. So we wanted to understand a bit better how this affected the biodiversity, or how it could affect the biodiversity in the area. So together with researchers in Denmark and on Gran Canaria, we did a set of experiments with leachate from the debris from the accident. So the types of chemicals that would leach out from the debris. And we looked at how that affected the planktonic community. Now, plankton is the very basis of the marine food web. They create oxygen. They act as carbon sinks. They're really at the center of the marine food web. So any effects that it may have on the tonic ecosystem can have devastating impacts across. And we saw in this study, apologies. What we saw in the studies was that for the phytoplankton, the growth decreased when they were exposed to this leachates from the burnt debris. The the, the sea urchins, their development changed and their size decreased. And the copepods, which is a type of zooplankton, their mortality increased and their hatching success decreased. So we saw a lot of potential impacts from this spill on the planktonic ecosystem. And what's also interesting is that we found a lot of different chemicals associated with the plastics. We found polycyclic aromatic hydrocarbons, which is not surprising given that there was a lot of oil and fire and burn things associated with these debris. There's also flame retardants and polychlorinated biphenyls and pesticides. Again, highlighting that plastics are not inert materials. They continuously absorb and leach toxic chemicals. And this is especially evident when we look at recycled plastics, because recycled plastics tend to sorb plastics. It becomes a mix of both the intentionally added substances and things that have been sorbed throughout the life cycle. So when we looked at recycled pellets from 23 countries, we found a wide range of toxic chemicals in these pellets, many of them banned. Now, you might be aware that there's ongoing discussions both under the Plastics Treaty, the Future Plastics Treaty, and under IMO on how to better address these issues. And at IPEN, we've started looking at the text that will be the start of the negotiations, and you can find some of our recommendations here. But we believe that one really crucial part is to address toxic chemicals throughout their full life cycle. Because as we can see here, plastics are spreading toxic chemicals even before they become products. Thank you very much.
Thank you, Teresa, for this excellent presentation. Just a reminder to the audience that you can put any questions you have to Teresa or to the following speakers in the chat. And now I would like to introduce our second speaker, Professor Shinya Takada. Professor Shinya Takada is a professor at Tokyo University of Agriculture and Technology. He has been working there for 39 years and just retired in this March. He's still organizing International Pellet Watch, which is a global monitoring program of persistent organic pollutants using beach plastic pellets. And he launched this project in 2005. During the last 20 years, he, his colleagues, and students analyzed pellets from over 100 locations from 68 countries in the world. Professor Takada has been studying the various organic pollutants together with persistent organic pollutants and plastics, and the results have been published in more than 200 peer-reviewed papers in international journals. Now he is the editor-in-chief of a journal, Environmental Monitoring and Contaminants Research. Professor Takada, the floor is yours.
Just a moment. Can you see the screen?
Yes, yes.
Yeah, okay. Thank you, Dorota, for your kind introduction. In my talk today, let me introduce our analytical results on legacy pollutants and plastic additives in pellets around the world. Plastics are lipophilic media and efficiently absorb persistent organic pollutants, POPs, such as PCBs and organochlorine pesticide from surrounding seawater. The concentration factor is up to 1 million. By utilizing this affinity of plastics with POPs, we have been conducting International Pellet Watch since 2005. We call the people to collect pellets on the nearby beaches and send them to our laboratory in Tokyo via airmail. Pellets arrived our laboratory like this. So far, we got the over 1,000 pellet samples from 68 countries. Arrived pellets were analyzed in our laboratory by using our instruments, and analytical results are shared with people through our website. Let me show you an example that is concentrations of PCBs in pellets as color categorization. Blue means no local pollution source, and green means lightly polluted, and yellow means moderately polluted, and orange means highly polluted, and red means extremely polluted. This is an example of the concentration of PCBs, and PCBs were used for a variety of industrial applications. PCBs are typical persistent, toxic, and bioaccumulative chemicals, and their usage was banned since 1970s. However, they are still accumulated in coastal waters in industrialized countries, such as West and East Coast of United States and Western European countries and Japan. In addition to these high concentrations in industrialized countries, recently we found very high concentrations of PCBs in African countries like these. These could be derived from the leakage from e-waste which introduced to these African countries. So far, we have been focusing on legacy pulps adsorbed from seawater, such as PCBs and organochlorine pesticides and polycyclic and petroleum hydrocarbons. However, plastic resin pellets contain additives such as antioxidants and also the flame retardants and UV stabilizers. Recently, we analyzed additive chemicals in plastic resin pellets. Among the additives, benzotriazole UV stabilizers were analyzed. These are UV stabilizers we analyzed. These compounds are compounded into plastics to prevent photodegradation of plastics. Among these, some are toxic, and some are already regulated by Stockholm Convention and regional governmental regulations. Additives are normally compounded to plastic products during the manufacturing process from pellets to final consumer plastic products. However, some UV stabilizers and antioxidant agents are compounded to industrial pellets as compound pellets and or master batch pellets. Also, the bleached pellets may contain recycled pellets, which must contain much higher concentrations of additives. Thus, we analyzed bleached pellets in the present study. Here we have analytical data on UV stabilizers in pellets. Concentration of some of 10 UV stabilizers are shown as height of purple bars. Concentrations of UV stabilizers are highly variable, but among 37 samples, 14 samples had higher concentrations. The 14 samples include remote islands, such as Macquarie Islands in sub-Antarctic Sea, and Ogasawara and Hawaii, and Hachijo Islands. All these are remote islands because there are no industrial factories to produce or handle plastic resin pellets on these remote islands. These high concentrations of UV stabilizers can be explained by that plastic resin pellets were subjected to long-range transport for hundreds kilometers or 1,000 kilometers without releasing UV stabilizers to seawater. These results have been recently published in this journal, Environmental Monitoring and Contaminant Research. The PDF is available from this QR code. And most recently, we analyzed antioxidant agent that is Irungaphos 168 and its degradation products. Irungaphos is more frequently added to polypropylene products, plastic products, but it's very easy to be oxidized to the degradation products such as TD, TBPP, and DTBP. Therefore, we analyzed TD, TBBP, and also DTBP, but we couldn't quantify Irungaphos 168 itself because of its highly degradable nature. We got interesting results. Concentrations of TBDBPP and DTBP in remote areas, in these areas, were much higher than those in industrial coast, where it's close to the source of pellets. The higher concentrations of degradation products in remote islands means degradation of Irungaphos and generation of degradation products occur during long-range transport of pellets. Okay, conclusion. We have reached conclusion. Plastic resin pellets contain legacy POPs and plastic additives. Plastic long-range transport the hazardous chemicals across the border. Benzotriazole UV stabilizers are transported to remote island without reaching. Degradation products of Irungaphos 168 are thought to be generated during transport to the remote islands. Therefore, resin pellets are toxic pellets and carrier of the hazardous chemicals to the remote areas. Therefore, international regulation of plastics, resin pellets, and hazardous additives is necessary. Okay, thank you for your attention.
Thank you very much, Professor Takada, for this excellent presentation. I think we all agree that the results are impressive, and congratulations on your project that is this year celebrating 20 years, it seems, so it's something to celebrate.
Thank you.
I will now move smoothly to introduce our third speaker for today, Hemanta Wittenash, who is the chair of Friends of the Earth International and the senior advisor of the Center for Environmental Justice based in Sri Lanka. Hemanta joined the environmental justice movement in the 90s, and in 2004, he co-founded the Center for Environmental Justice, the most visible environmental organization in Sri Lanka today. So looking very much for your presentation, Hemanta, and please go ahead.
Thank you very much for inviting me to speak in this session. So let me share my PowerPoint. I hope you can see the PowerPoint presentation here.
Yes, but it's not, it's still, yes,
all right.
Excellent, thank you.
All right, actually, this is one of the picture of a fish, so inside the mouth you can see all the plastic pellets. So some of the things that, Therese already mentioned about that people, the fish mimic this as the food item, so they eat them. Right. These are some of the pictures from the beaches when the express pearl ship disaster happens. So this there's a long story, but the ship had about 25 metric tons of nitric acid, which is the main reason for the explosion. But it had 1,680 metric tons of plastic nurdles, both high density and low density polyethylene. So we calculated maybe around 85 billion pieces of microplastics. And also 1/3 of the shipment was about epoxy resin, which is about 9,600 metric tons. You know, when the epoxy resin burns, so it releases bisphenol. You know, so bisphenol is a carcinogenic chemical, which we have done other research in Sri Lanka, checking the bisphenol levels of feeding bottles. You know, together with the IPEN, we have done that research as well. So then it also had a highly hazardous lithium-ion battery, one container, and also bunker fuel, lead, copper, and there are many other items on this ship. So when the ship explosion happened on the 26th, actually, so there were plastic nurdles all over the beaches, the white pellets, but 2-3 days later, it has spread more than 2/3 of the country coastal zone. So even the national parks and inland water bodies, everywhere you found these kind of plastics. And few days later, we found different colorings of the plastics, from red color to blue color and yellow, and all different colors. Over the time, it changed the color. So which is one of the way to look at that, how other chemicals are binding into the plastic pellets in the nature. So I have taken this picture, this slide from the publication we produced together with the IPEN. Basically, this shows how the different types of chemicals are in various levels of water. You can see some of the heavy things like the lead, copper. It goes to the bottom, but the oils and plastics spreads, and then it moves from one place to other place. So this was the situation during that time in the ocean. You know, it was a strong, windy, rainy days in this time. So the water circulation pattern you can see. So the scientists are saying that this plastic pellets and the rest of the chemicals, it has moved around the country, as well as it has gone to the Indian coast and to the Andaman Island and Burma and that side as well. So I think it is not a local, although it was a main impact is a very local, but the whole pollution is not very local. So it may have spread already thousands of kilometers by the various beaches. We done two research. You know, actually the first research we done with the IPEN. So Antares was one of the main author, but Chalani Robesinger from our organization, Sarah, and few other people joined. But then we also done a second research together with the University of Jawadhanapura. Professor Padmalal Manage was the leading scientist in this one, but rest of the scientists also engage in different levels. What we found in the first research, so we found several heavy metals. You know, it was attached to the burned lumps of plastic. You know, there were many different chemicals like the cadmium, lead, etc. Then we also found the UV stabilizers like the polyaromatic hydrocarbons. The UV326 was heavily available, from 31 to 220 nanograms. Then bisphenol also found in one sample, and then there was a number of the samples with polyaromatic hydrocarbons. But these, interestingly, the two locations where it shows Sarakkuwa and Bopitia, which is actually the closest beach to the shipwreck. The Panadura and Kalutara are a bit far away, maybe about 20-25 kilometers away. So we found the high concentration very near the beach in Sarakkuwa, which is the closest proximity to the ship. Then the concentration of polyaromatic hydrocarbons also comparison to the other consumer products for children and adults, and we found very, very high levels again, and it was so we found two different locations here we have marked. One is Sarako, which is the closest point, then Kalutara, which is far away, but Kalutara also we found very high levels of these polyaromatic hydrocarbons. Then this graph shows in various other chemicals related to the polyaromatic hydrocarbons. The other information or other results we got is actually 83% of the samples contain barium, and bromine, mercury, manganese, and antimony, and these kind of heavy metals. They all have impacts on the human body, and it has health impacts, and also it can accumulate in the fish body and then come through the food cycle to the human. These are actually done with the second research which we have done with the University of Sri Jawadapura by Professor Padmalal Manage, and we tested this kind of shellfish as well as shrimp and some of the small fish, and we found high levels of lead, cadmium, chromium, zinc, and all these heavy metals in the body of these animals. And also we found maximum allowable, the level is very higher than maximum allowable limits. This is actually accumulating in the food cycle, so that's why it is so dangerous. But then we also found this tributylene, which is one of the chemical very harmful. It's an endocrine disruptive chemical. We found very high levels, very near the shipwreck area, but also in some other areas as well. Interestingly, we also found some of the cyanotoxins. We found several cyanobacteria, and this success toxin is one of the neurotoxin which we found in the waters very near the ship. We found very high concentrations. This is something serious, and we don't know the current situation, but this research was done about 1 year after the ship accident. The problem is actually right now I don't see any research happening around this area. I don't know actually what the science government departments or the universities are doing, but to my information, I think there's no big effort to make the research, and we found the cost is very high. Even sometime when the researchers like Professor Mettika, when they import certain chemicals to do the testing, and the customs department has asked for huge money, tax money, so therefore it has discouraged scientists doing this work. So unfortunately, I don't see any new research happening in this area, but I think we really need to continue this kind of testing. Otherwise, so we don't know how these chemicals are moving along the food cycle and coming back to the humans as well. Thank you.
Thank you, Hemant. I definitely agree that the research and the data are necessary. I already see some questions popping up in the chat, but before we will move to our Q&A session, I would like to introduce our fourth and last speaker for today. It will be Megan Keaton from Fidra. Megan is a senior project officer at Fidra, and she supports the chemical and plastic pollution work at Fidra, including the Great Global Nurdles and IPEN, so famous of Unfamous Forever chemicals projects. Megan will now give a brief overview of the resources Fidra has developed on chemicals and Nurdles, which organizations can use to support their own work in tackling these issues. Megan, the floor is yours.
Thank you. Thank you very much, Dorota, for the introduction, and to all our speakers as well today. I'm just going to get my slides up quickly. Okay. Yes, so as mentioned, I'm just going to give a very quick overview of some resources that we have on chemicals and Nurdles, which organisations are welcome to use. A very quick introduction for those who might not know who we are. So Fidra are an environmental charity based in Scotland, and we are known for, in this space, running the international citizen science project, the Great Global Nurdle Hunt, which collects data on plastic pellet pollution all around the world using our online map. So we ask volunteers to go out to their local area, count the number of plastic pellets they see, and record them on our map. If you are interested in accessing this data from our map, please do get in touch. We're happy to share it with you for research and other purposes. And also at Fidra, we have several other projects, as Dorota mentioned, on other chemical pollutants, such as PFAS and chemical flame retardants. So please do head to the Fidra website, which is just in the bottom right there, if you're interested in any of those topics. But just a quick overview of some other resources that we have. So within our Great Global Nurdle Hunt project, we also have our Nurdle Hub, which houses key resources for organisations such as yourselves who are working on pellet pollution. It has a great deal of information on different solutions to plastic pellet pollution, not just those shown on the screen of how to use data and evidence to support solutions work, but also wider solutions to plastic pellet pollution, which we've had a lot of opportunities with this year, such as the EU regulations on plastic pellets, which just got passed a couple of weeks ago. We ran a webinar on this just a couple of weeks ago as well. And we also have news bulletins summarising the outcome of that, and lots of information on the Global Plastics Treaty as well. So please do head to our hub. The website link is up in the top corner there if you're interested. And just quickly, specifically on the resources related to chemicals and Nurdles. So first of all, demonstrating that Nurdles contain toxic chemicals can serve as a powerful argument for solutions to these issues, as our speakers have all alluded to today in their presentations. So one key resource that we do have is our Mapping the Global Plastics Supply Chain report. It offers a sort of comprehensive analysis of the extent of the plastic supply chain and the scale of pollution. It's a great overall resource for anyone who is working on plastics in general. It has key information at regional levels all over the world, for anyone interested, and it also looks into sort of examples of acute and chronic losses of pellets, as well as touching on impacts of pellet pollution on communities, livelihoods, ecosystems, and it does touch on toxic chemical impacts as well. So this graph on the screen is just showing sort of estimated pellet loss up until 2030. The sort of blue line represents minimum estimates of pellet loss all across the world, and the orange line estimates the maximum pellet loss estimates up until 2030. And sort of the report alludes to that basically, the larger number of pellets released into the environment is intrinsically linked to toxic chemicals being released in our environment, just as was also highlighted in the other presentations today. And we have also just launched on our Nurdle Hub our Chemicals and Nurdles webpage, which summarises a lot of the information discussed here today, all in one place, as well as also the key reports that were also highlighted today in some of the journal papers as well. So it's all easily accessible in one place, So please do check that out. And as well as sort of web pages and reports, we also have lots of useful images to be used in your work. Please do just feel free to go and download these. We have specific ones related to chemical pollution as well, such as these infographics. So this infographic here is just using statistics from our mapping supply chain report to sort of demonstrate, how toxic chemicals are in plastic pellets and getting into recycling products in Europe. We also have this new infographic as well, showing just how Nurdles can pollute chemicals throughout their entire life cycle, which is free to use. So yeah, finally, if you have enjoyed this webinar, we have lots more on our YouTube channel, covering a whole range of topics, including the one that I just mentioned on EU regulations, which happened a couple of weeks ago. We've also just started a series on personal impact stories as well, which you can also find on our YouTube channel, which kind of talks to various people and community groups around the world who have been impacted by pellet pollution. So please do check them out. But that's it. That's all from me. Just a very quick overview. Thank you very much. I will hand back to our chair.
Thank you, Megan. So now we reached to the fascinating moment. We can open officially our Q&A session. Just looking at the questions in the chat, I see one very, well, say technical. And I'm guessing this is to Professor Takada, but if anyone from the speakers also can add, please do so. So the question is, what would be the concentration of persistent organic pollutants in the environment compared to levels found in the pellets? So do we have any estimated ratio?
Yeah, thank you. We have the concentration of POPs in pellets reflects the concentration of POPs in seawater or bivalves in the site. We have the good correlation between concentration of PCBs in pellets and concentration of PCBs in mast cells collected from nearby sites on the global scale. This means the concentration of POPs in pellets reflects the concentration, the pollution status of the sites. But this is a story about the POPs absorbed from seawater. But if we focus on the plastic additives, story is different. The concentration of the additives, benzotriazole UV stabilizers, were high in remote islands. But in the remote islands, the seawater doesn't contain high concentration of the UV stabilizers. Therefore, in that case, the pellets or plastic are source of additives to seawater and biota in the seawater. Thank you.
Thank you. Thank you very much. It's and there is a new question that a little bit also maybe well, I will ask first you, Professor Takada, to answer. Have there been any trends identified in the types of chemicals detected in pellets over time?
Yeah, question to me. Yeah, thank you for the question. Regarding the PCBs, the concentrations of PCBs in pellets have been decreasing. We compared the pellets collected in 2005 or 2010 with those in the pellets collected in 2020 at the same site. Concentration of the PCB decreased by half during 15 or 20 years. This reflects the decrease in legacy pollution, but even 10 or 20 or 30 years after ban of the usage of PCBs, pollution is still there. And in my sense, the pollution half-time is not so short. Pollution is decreasing, but it's slow. So legacy pollution is still ongoing. Thank you.
Thank you very much. I don't know if if other speakers would like to add something to this. Yeah, if yes, just jump in, please. Just trying to read. Maybe before I will go to another questions from the chat, I will just abuse a bit my role as a chair, and I would like to ask, because also there was mentioned a couple of times, the famous PFAS. And we know they are extremely persistent. We know that they are everywhere in the environment. And I just wonder if there is any research already going on to look at the correlation, if any, finding PFAS in pellets, Nurdles, or is something planned. I don't know if one of the speakers can jump in.
Can I?
Yes, please.
Yeah. And in my understanding, PFAS is basically water-soluble pollutants, not so hydrophobic. Therefore, the concentration of the PFAS in pellets may be lower than the other POPs. That's my understanding, but maybe Megan has different opinion.
I'm not so sure myself, to be honest. It's an interesting question, and potentially something that I should definitely look into.
Well, I see Teresa has something to say.
Yeah, I would agree with Chigi that that's true for many of the PFAS. PFAS are such a wide range of different types of chemicals, so there's different types, of course. I'm not personally aware of any projects that have been looking specifically at PFAS and plastic pellets, but I would assume that you would be able to find them, especially in recycled pellets, where they would be recirculated into new products.
Thank you. I would like to also this is actually quite long, so I'll just read the questions as comment from the chat. It's posed by Falco Martin. Thanks to insightful presentation, so far plastic pellets are not classified as dangerous good when transported across the world, despite the toxicity evidence. Do you think the plastic pellets meet the dangerous good criteria for hazardous substances, for example, which could improve their transportation? From my knowledge, it seems that the tests are outdated, not adapted, and don't allow this to happen for now. So yes, I think this is an excellent question that each of the speaker can provide a short feedback. So Teresa, I see you as the first on my screen, so please start.
Of course. So this is a really interesting question. So for some background here, I think it was Falco who asked, right? So for some background here, I know that many of you might be aware of the IMO is currently looking into how to classify plastic pellets and whether to classify them as hazardous or harmful or in some other way. Now, the way that they are classified under IMO is quite complicated. There's a lot of different classification schemes that you would follow depending on which type of classification that you would go by. And I'm not confident that I have all of the criteria fresh in my mind right now, but I would say that it is quite clear based on the existing research that plastic pellets can pose hazards to the marine environment and are harmful to the marine environment. And when we look at chemicals, we can also see that they contain a lot of hazardous substances. So I hope that at least answers part of the question.
Thank you, Teresa. Maybe now I will give the floor to Samantha. Do you have any feedback on this very interesting question?
Yeah, it's an interesting question, and somehow we definitely need to categorize this under the harmful substances, because so we felt the danger, the damage, so because one thing, I mean, at the very beginning when Sri Lanka make this proposal to the IMO, I was also supposed to speak, but this Japanese chair who chaired this meeting, so he didn't even allow, and not even 2 minutes to the Sri Lankan government to make this proposal. But what I felt actually, there were 1,680 metric tons in just one ship with a very breakable packages, and that was the biggest reason for them. Even if it is hazardous, there should be some guidelines how they can transport and what amount they can transport, because compared to some other incidents in South Africa, Hong Kong, and all of them, so they were about 50 metric tons and etc. But this is about 1,800. 680 metric tons in just one shipment. So that's one of the thing. It's not only the plastic, but also the transportation guidelines. So but second will come later, because if you classify this as a hazardous substances, adequately cover the transport as well, so then only so you will come with that kind of guidelines. But at the moment there's no such guidelines, so I think that's why the danger was so high. I mean, the damage was so high in Sri Lanka. And also it's a floating item. Now we have all the results that it binds with different other chemicals. It can transport those chemicals into the other environment, other food chain as well. So I think it is not just a static pollution, but it is moving from one place to other place. So I think these should be considered when they are making sort of a I mean, the kind of definition for what kind of substances this pellet is. That's my understanding.
Thank you. And finally, Professor Takada, would you like to add something?
Yeah,
Your point of view?
thank you. Regarding the POPs adsorbed from the surrounding seawater, or the virgin pellets might be not hazardous. Hazardousness could be derived from the chemicals itself, PCBs or DDTs or some others. But if we see the additives, the polypropylene pellets are hazardous themselves, in my understanding, based on our research during last 5 years. Before that, we focus on the adsorbed chemicals. If we focus on adsorbed chemicals, the pellet itself may not be hazardous. But if we focus on additives, polypropylene pellets are hazardous, because polypropylene are plastic polymers which are easy to be weathered. Therefore, the polypropylene pellets must contain some antioxidant agents or UV stabilizers. Those are hazardous. Therefore, the polypropylene pellets contain the hazardous chemicals very frequently. Therefore, we should categorize polypropylene pellets as hazardous items. Regarding the polyethylene pellets, we should consider much more carefully. But regarding the polypropylene pellets, in my sense, I can say it's hazardous. Thank you.
Thank you. I have the feeling that this kind of discussion will be back somewhere at some kind of forum. So let's see how it will go. It's definitely a lot of different angles we can take here. Because I'm conscious actually of the time, we have 4 minutes. So just really very last, maybe there is somewhere in the chat, somebody from the audience mentioned some legal consequences of the case. I think it's in Sri Lanka, if I'm not wrong. But my question would be, because it's often we use this word today, pollution, damage, but very often we are asking ourselves how can industries at the end be held accountable for the chemical contamination, and it's linked to the Nurdles. So if anybody of you would like to volunteer to give the answer, I'm guessing it's another big question, but that's also apparently something that is also entitled in the currently global plastic treaty discussion. So can we actually really make hold the industries accountable, and how? Is there anyone volunteering?
Yeah.
Yeah.
Can
Yes,
I
Samantha,
say
please.
something? So this is not easy, especially in most of the developing countries. The first you have to make the scientific research, then you have to prove that it has some impacts on the health of the human health or the environment, and then so you have to argue these things in the courts. So with the non-scientific people, the judges, so they are very, very, very technical. For example, we have a lot of good news about the glyphosate in United States, but then so we made a proposal, we made a court case in Sri Lanka soon after to ban glyphosate in Sri Lanka, because there was a 5-year ban for the glyphosate in Sri Lanka, but then they lifted this ban. So then we filed the legal action. Then one of the judge argued that even the cancer medicines has some sort of a negative impact, so therefore they will not allow us to proceed with this case. So that's the sort of arguments coming from the judges. It is not so easy. Unless, but there are certain situations now. For example, the lead in paint, we were successfully filed the legal action in the court, and the court asked the Consumer Affairs Authority and Minister of Health to come up with the right standard, and we were able to bring it down to 90 parts per million, which was like 135,000 parts per million when we tested the samples. So we could, if we have the standard, then definitely we could bring them. But there are certain standards that are agreed by the WHO and sometimes the EPA, sometimes the European Union. So they are not the same in many of our countries. So I think there are different levels of difficulties, but I think so the issue is actually, so if we have some kind of good case studies coming from other countries, definitely we can try, but not necessarily so they will accept all these case studies. We have tried number of times, but sending back the waste, plastic waste, back to United Kingdom, that was very successful in our case. But on the special chemicals, it is not so easy. Thank you.
Thank you. And I just looking at the some Professor Takada want to add something. It's not really necessary, but just and I see actually that is in my clock. It's 11 o'clock, so we reached the end of this event. I think we could really continue this discussion for quite a while. But at the moment, well, I would like to thank, first of all, Fidra for organizing this very interesting and relevant webinar, all the speakers for their excellent contributions, and everyone who joined for spending this hour with us. So I would like to wish everyone a great rest of the day, and goodbye.